What's good, math family? In this video, we're going to look at special right triangles and we're going to practice on how to find the missing side lengths based on these special relationships. We're going to start off with the 45, 45, 90 triangle. And as we start off, just remember, they may not always put the 45-degree angles inside of the triangle for you to know. They may have lines like this to let you know both of these legs are equal, both of the angles are equal, or they may just put 45 degrees for one angle. You have to know and assume the other one's 45, especially if we're talking about a right triangle. So when we look at the angle relationships, I know my legs, right, are the same. And if I want to find the hypotenuse, I just take my x multiplied by radical 2. So we know the leg should be 10 radical 2 for this, and that is it. Now, there's other problems where what they do is they give us the hypotenuse. Now they want us to find the legs. So if we're looking at this, right, understand whatever our leg was, we had to take it, multiply it by radical 2 to figure out what is the hypotenuse. So if we're working backwards, we're going to take the hypotenuse and now we're going to divide it by radical 2, meaning we're going to rationalize our denominator because we can't have a radical there, right? So now we're dividing by radical 2. I'm rationalizing it. So this turns into 15 radical 2 all over 2. So if they're asking me for the legs of this triangle, and we only had the hypotenuse, divide by your radical 2, and we should get an answer of 15 radical 2 over 2. Now, some of us may be saying, how do we know if this is sure? If you want to double check, right, if this is our leg to go from here to here, we need to multiply by radical 2. So let's do that. So I multiply by radical 2, right? What happens in the top is we're going to have 15 times the square root of 4 over 2. Once we simplify, this turns into 15 times 2 over 2, which gives me 30 over 2, which is equal to that hypotenuse, 15. So we know this is correct. And then in our last example, same thing. And just remember, guys, or math family, I should say, if they rotate the triangle or flip it, the angle relationships are the same. So I just want to make sure you guys understand that. So let's get some space right here. So we do the same thing over, right? We have 3 radical 2. We have the hypotenuse. Now we're trying to say to ourselves, okay, what is the leg? So to find the leg, we're just going to divide by radical 2. See, right here, what we could do to simplify is just understand this is a fraction, meaning what? I could cancel these out, and I know that my leg or legs are going to be equal to 3. But let's just say we went through and we rationalized, right? So I multiply by radical 2 on the bottom, multiply by radical 2 on the top. What this turns out to be is 3 times 2 over 2. So this turns out to be 6 over 2, which is equal to 3. Just want to show you guys how to solve if you sometimes make mistakes. And if this video has been helpful for you, smash the like button for us, comment down below so we could put out more and similar content to this. And now we're going to go over to our other special right triangle. We're moving over to the 30, 60, 90 triangle. And honestly, family, I think this one is a little bit more harder compared to the 45, 45, 90. But one thing we need to remember and understand is that the short leg is going to be the 60-degree side, meaning it's just x. And for us to find the long leg, right, which is the 30-degree side, we got to take that x multiplied by radical 3. And then for the hypotenuse, we just take x multiplied by 2. So when we look at my first example, we have the long leg. And if I want to find the short leg, I got to work backwards, meaning I'm going to divide my 24 by radical 3. All right, so I have 24 over radical 3. I'm going to rationalize, right? So I multiply by radical 3, multiply by radical 3 on the top. What I get is 24 radical 3 over 3. I can reduce that fraction. Then once I reduce the fraction, I'm going to get 8 radical 3 as the side length for the short leg. Now that I know that, right, it's easier for me to get the hypotenuse now. So all I got to do is take this, multiply it by 2. So I have 8 radical 3 times 2. And when we properly multiply radicals, right? We multiply coefficient with coefficient, radical with radical. So 8 times 2 gives me 16. Radical 3 stays the same because there's not another radical to multiply with it with. So hypotenuse is 16 radical 3. Short leg is 8 radical 3. Now, in our second example now, what they did was basically the same thing. They gave us the long leg, and we need to find the short leg so we could then find the hypotenuse. So I'm going to do the same exact thing. I'm going to take 15, put it over radical 3, and let's rationalize. So now I rationalize, and what I get is 15 radical 3 all over 3. Meaning what? I could reduce this fraction, and x for the short leg is going to be 5 radical 3 as a final answer. So now that I know that, like we said, hypotenuse is 10 times easier. I'm going to take this and multiply it by 2, and I'm going to get 10 radical 3 as a final answer for the hypotenuse. Now, last example, same exact thing. They gave us what? They gave us the short leg. So if I want to find the hypotenuse, we're going to take 7, multiply it by 2. So this is going to be 14 for the hypotenuse. And if we're now specifically talking about the long leg, we just got to take that base, that x, multiply it by radical 3. So this right here, that long leg, should be 7 radical 3. And that is my final answer. Really hope that this review was helpful for you, math family. We've linked down similar topics, geometry EOC, you can find down below, as well as how to use sine, cosine, and tangent to find missing angles or side lengths. Really hope this video review was helpful for you guys. Smash the like button, subscribe to our channel, and thank you guys so much for continuing to support Algebra 1 with Mr. Peters. Thank you guys again.